Okay, and let's continue with another example. Find the area under the curve y equals to sin x above y equals to 0 from x equals to 0 to x equals to pi. Okay, firstly, let's understand what are we looking for. Okay, and let me sketch this sine function on the coordinate system, and we know that the sine function is like that. This point is of course pi, and this point is pi over 2, okay, and this point is 0, and y equals to sin x, okay, and the x equals to 0 to the x equals to pi, that means from here to the here, okay, and the y equals to 0. The previous question I did mistake, okay, and I write here x equals to 0. Of course it's not true, okay, this line must be y equals 0, okay, and the y equals 0 line is here on the x-axis, that means, okay, and our shaded region, as you see, colored with the green pen, okay, and now we are looking, and we want to calculate the area of our region, right? And now what will we do? Okay, and you can write this area by the integral from 0 to pi, okay, and the sin x del x, okay. My friends, okay, please look at this portion, yellow portion, and the pink portion, okay. Okay, if you take the y-axis, or if you shift the y-axis to the pi over x equals to pi over 2 line, that means, okay, when you shifted the y to here, okay, you can say now our sine function is even function, okay, so maybe you can calculate this integration, okay, integral from pi over 2 times to pi, okay, sin x del x, okay, or you can say 2 times integral from 0 to pi over 2 sin x del x, okay. All of them are same, right? And after that, let's use this integration, and the a equals to, okay, integral of sin x equals to minus cosine x, okay, evolution bar from 0 to pi, it equals to minus, okay, and the cosine pi equals to minus 1, minus, and the cosine 0 equals to 1, okay, and equals to minus 2, it equals to plus 2 unit square. Okay, and continue with the method of substitution. Okay, and I want to give you some elementary integrals about it. second, third, fourth. Integral 1 del x, it equals to x plus c, and integral x del x, it equals to 1 over 2 x squared plus c, and integral x squared del x, it equals to 1 over 3 x cubed plus c, and integral 1 over x squared del x, it equals to minus 1 over x, okay, plus c, five, 6, integral square root of x del x, okay, you can say integral x to the power of 1 over 2 plus c, okay, I'm sorry, del x, and it's equal to x to the power of 3 over 2 over 3 over 2 plus c, so it's equal to 2 over 3 times integral x to the power of 3 over 2 plus c. And the sixth one, integral 1 over square root of x del x 2 times square root of x plus c, okay, the 7, 8 and 9, integral x to the r del x, it equals to 1 over r plus 1 x to the power of r plus 1 plus integration constant, and the r is not equal to minus 1, okay, because of the denominator part will be 0, okay, and the integral 1 over x del x is equal to ln absolute x plus c, and the integral sine ax del x is equals to minus 1 over a cosine ax plus c, okay, and the 10, 11, 12, and you can find lots of some elementary integrals, okay, end of your book, okay, please look at them. Integral cosine ax del x equals to, okay, 1 over a sine ax plus c, integral secant square ax del x equals to 1 over a tan ax plus c, integral cosecant square ax del x equals to minus 1 over a cot ax plus c integral 1 over square root of a square minus x square del x, it equals to inverse sine x over a plus c, and the a is greater than 0, and the integral 1 over a square plus x square del x equals to 1 over a inverse tan x over a plus c, and the integral e to the ax del x equals to 1 over a e to the ax plus c, and the integral b to the power of ax del x, it equals to 1 over a times ln b times b to the power of ax, okay, plus c, and the integral cos h ax del x equals to 1 over a sin h ax plus c, and the last one integral sin h ax del x, it equals to 1 over a, okay, cos h ax plus c. Example: integral x over x square plus 1 del x, okay, and the let, okay, substitution rule, let choose u by the x square plus 1, okay, and the del u over del x, okay, equals to 2x del x, and then as you see x del x will be del u over del x times, okay, and the, I'm sorry, this part will be del u over del x equals to 2x, okay, and the del x will be equal to, okay, del u over, okay, 2x, right? And then I will use these two part, okay, and I will use the substitution rule on the integral, okay, and the what will it be, okay? Look at that. When I have just found the del x equals to del u over 2x, so integral, okay, x over x squared plus 1 was u, okay, times, and the del x was del u over 2x, del u over 2x, okay, and this part will be cancelled, and after that, because of the multiplication rule, and the integral, okay, del u over u, okay, and after that, I'm sorry, and the 1 over 2, of course, because of the here is 2, okay, and after that 1 over 2 times ln absolute u plus c, and the let gonna write it I, okay, and the I equals to 1 over 2 times ln absolute x squared plus 1 plus c. Integral, okay, sine of, okay, 3 ln x over x del x, okay, and the let u equals to 3 ln x, okay, so del u over del x equals to 3 times 1 over x, right, and the del u equals to 3 over x times del x, right, and the integral, okay, sine of 3 ln x over x del x equals to integral sine u over x and the del x from here, and the maybe del x equals to, okay, x times del u over 3, okay, and we will use only this part, times x times del u over 3, okay, and this part will be cancelled, okay, we have only u terms as you see, and after that okay, 1 over 3 integral sine u times del u, and we know that it's equal to 1 over 3 times minus cosine u plus c, and it's equal to minus 1 over 3 cosine of 3 ln x plus c. Example again. Integral e to the x times square root of 1 plus e to the x del x, okay, and now you can sometimes use the v letter, okay, and the or u letter, it's not important, okay, on the substitution letters, okay, we can call them 1 plus e to the x. Let's choose the v like that, and the del v over del x, it equals to e to the x, okay, so we can say del x equals to, okay, del v over, okay, e to the x. Now we will use only these two substitution form, okay, and I mean that integral equals to, okay, e to the x square root of 1 plus e to the x del x, it's equal to integral, okay, and the square root of v times, okay, del v, and of course some cancellation, and after that we can think about it, integral v to the power of 1 over 2 del v, so it's equal to 2 over 3, okay, and the v to the power of 3 over 2 plus c, and it's equal to 2 over 3, okay, and then 1 plus e to the 3 over 2 plus c. Substitution in a definite integral. Integral from a to the b f of g of x times g prime x lx, it equals to integral from a to the b fu del u, and don't forget g of a equals to capital A, g of b equals to capital B. You must change the boundary values when you substitute in a definite integral. Don't forget it. And the trigonometric integrals integral tan x del x, it equals to ln of absolute secant x plus c. And of course you can choose the u equals to cosine x, and the del u will be minus sine x del x, and after that you can find this integration. I mean when you choose the u for here, and the let me reminder, if you choose u equals to cosine x, because of that tangent x equals to sine x over cosine x, and the del u will be minus sine x del x, and after that your integration will be integral minus del u over u, so it's equal to minus ln minus ln absolute value of cosine x plus c, and it's equal to ln of absolute cosine x to the power of minus 1 plus c, because of the properties of the logarithm, and after that you can say it's equal to ln of secant x plus c. This is only for first trigonometric integral, which is the tangent x del x, and they continue the second one, and it's the cot x del x is equal to and the ln of sine x plus c, and the integral secant x del x, it equals to ln of absolute secant x plus tangent x plus c, and the integral cosecant x del x, it equals to minus ln of cosecant x plus cotangent x plus c, example. Integral cosine square x del x equals to 1 over 2, okay, x plus sine x times cosine x plus c, and another example, sine square x del x, okay, it's equal to 1 over 2 times, okay, x minus sine x times cosine x plus c. Why? Because I've used here cos square x equals to 1 over 2 times, okay, 1 plus, okay, cosine 2x, okay, in here, and for here sine square x, it equals to 1 over 2 times 1 minus cosine 2x. Okay, and example again, integral sine to the 4x del x. Okay, what will we do? Okay, I have just given the cosine square x, okay, equality, and it's not hard to understand you, and the integral sine 4x del x equals 1 over 4 times integral, okay, and the 1 minus cosine 2x square, okay, del x, and after that 1 over 4 times integral, okay, and the 1 minus 2 cosine 2x, okay, plus cosine square 2x del x, and then 1 over 4 times, okay, and the x minus sine 2x, okay, and let me write it the cumulative form, okay, and the x over 4, okay, and the minus 1 over 4 times sine 2x, okay, and the plus 1 over 8 times integral, okay, and the 1 plus cosine 4x, okay, and the del x, and after that x over 4 minus 1 over 4 sine 2x, okay, plus x over 8 plus 1 over 32 sine 4x plus c, okay, and what can you say about the integral cosine to the 4x del x, for example, okay? You must choose it. You must solve this question at your home, and evaluate integral tan square x del x, and we know that the tan square x equals to secant square x minus 1 So integral tan square x del x equals to integral secant square x minus 1 del x, and it's equal to integral secant square x del x minus integral del x, and it's equal to tan x minus x plus c. Okay, this is the first method. Okay, and the second method, integral tan square x del x equals to integral tan square x plus 1 minus 1. Okay, nothing will be changed. Okay, del x, and it's equal to integral tan square x plus 1 del x minus integral del x, and it's equal to tangent x minus x plus c. This is the second method to calculating or to evaluate the integral tan square x del x. Okay, let me continue giving these some examples. Integral del x over e to the x plus e to the power of minus x, integral e to the x del x over e to the power of 2x plus 1. Okay, and that means, what will we do now? And let u equals to e to the x substitution, and del u will be e to the x del x, right? And after that integration, okay, del u over, okay, u square plus 1, okay, and it equals to inverse tangent u plus c, and it's equal to inverse tangent, okay, e to the x plus integration constant. Example, integral sine square x cosine square x del x, it equals to integral a sine 2x over 2, because of we know that sine 2x equals to 2 sine x cosine x, right? And after that square del x, and we know that the 1 over 4 integral sine 2x equals to 1 over cosine 4x over 2 del x, so it's equal to x over 8 minus sine 4x over 32 plus c. Example again, and the integral sine to the 6x del x, okay, And what will we do? Firstly, it equals to, okay, you must write it by the terms of cosine 2x, we know, and the 1 minus cosine 2x over 2 cube del x. And when you extract, okay, this cubic form, and you will obtain 1 over 8 integral, okay, and 1 minus 3 cosine 2x plus 3 cosine square 2x minus cosine cube 2x del x, and the x over 8 minus 3 sine 2x over 16, and the plus 3 over 16, okay, and the integral 1 plus cosine 4x del x, okay, and the minus 1 over 8 integral cosine 2x times 1 minus sine square 2x del x, okay, and let u equals to sine 2x, and the del u will be 2 cosine 2x del x, right? And after that continue 5x over 16, because of here will come 3 over 16, 3x over 16, and here will be 2x over 16, and it will be 5x over 16, and minus 3 sine 2x over 16 plus 3 times sine 4x over 64, and minus 1 over 16 integral, okay, 1 minus u square, and the times, okay, and the del u, because of the cosine 2x del x was del u over 2, and after that 5x over 16 minus 3 sine 2x over 16 plus 3 sine 4x over 64 minus 1 over 16, and let me write it the cumulative form, and the minus sine 2x over 16 plus sine cube 2x over 48 plus c, and as you see, sine 2x and sine 2x, and the addition, you can add each other, 5x over 16, okay, minus sine 2x over 4 plus 3 sine 4x over 64, and the plus sine cube 2x over 48 plus integration constant. It's a good exam question, right? And my friends, don't forget, and maybe another example, integral from 0 to pi over 2. Yes, square root of 1 plus cosine x del x is equal to integral from 0 to pi over 2 square root of 2 cosine square x over 2 del x, and it equals to square root of 2 integral from 0 to the pi over 2 cosine x over 2 del x, and it's equal to 2 times square root of 2 sine x over 2 from 0 to the pi over 2, okay, and you will obtain the q values after that, okay, and